Once again, good morning. And today we'll discuss about lesson 2.2. It's on graphing quadratic functions. Yesterday, we have talked about the standard form of the quadratic function. That's f of x equals ax squared plus bx plus c. And we also learned about the vertex form of the quadratic function. Today, let's learn how to graph a quadratic function. To start, let's recite today's memory verse. It's found in Proverbs 3, verses 5 and 6. It says, "Trust in the Lord with all your heart, and do not lean on your own understanding. In all your ways, acknowledge him, and he will make your paths straight." At the end of today's class, we'll be able to, number one, graph a quadratic function. We'll also learn how to determine its domain, range, intercepts, axis of symmetry, vertex, and the direction of the opening of the parabola. And lastly, we'll be able to determine the zeros of a quadratic function. Now, before we go there, let me first share with you the history of a parabola. Now, what is a parabola? We commonly see it as a path of a projectile, or we say the curved path. When you shoot a ball, when you play Angry Birds, we see the path is forming a parabola. But when did it start? It started with the ancient Greeks. Menaechmus appears to have studied the parabola and the hyperbola and the ellipse. I'll show you what is a parabola, hyperbola, and ellipse. Apollonius of Perga also studied the conic sections. If you say conic sections, these are different sections that are done from a cone. Now, then Galileo noticed that the projectile path forms a parabola. You see, the parabola looks like this one. It could go up or it could go down. And Kepler also noticed that the planets do not move in perfect circles, but they move in an orbit that is elliptical. And so these conic sections, the parabola, hyperbola, ellipse, and circle, were studied. Now, what are these? I told you a while ago of conic sections. These are two cones. Imagine that. If you slice the cone in a slanting type, we get a parabola. If we slice the cone parallel to the ground, we form a circle in between. If we slice it for the full cone and slant, we get an ellipse. Usually we call it oblong when we're in elementary. But as we go higher in education, we learn it's an ellipse, not just an oblong. And if you slice it this way, we get hyperbola. It means two parabolas. Now, how do we graph parabolas? These are the parts of a parabola. Let me use my pen. The first is the vertex. The vertex is the lowest point of the parabola. Or if the parabola opens downwards, it is the highest point of the parabola. Now, the axis of symmetry is this one. It is the vertical line that passes through the vertex, and it makes the right side similar or a mirror image of the left side. If a parabola opens downwards, then the axis of symmetry is here. The next is the domain. If we say domain, it tells us what are the possible values of my x coordinates. All of these values are called domain. And if we say range, these are all the possible values of your y that will make your function true. Next, intercepts. Intercept is also the same as intersect. Now, if we say X intercepts, it tells us what points in the X. Remember, if we have our coordinate plane, this is called the X axis, and this is the Y. If we say X intercepts, then what points in the X axis does your graph intersect? So this one. So the X intercepts are found in the X axis. If we say Y intercepts, what points in your Y axis did the graph intersect? So in here, this is your X axis. So these are your X intercepts. This is your Y axis. So this point where the graph crosses the Y axis is called your Y intercept. Now remember, your X intercepts are also called the zeros of the function. I think it can be spelled as with an S or with an ES. Plus, remember, zeros are also called roots of the quadratic equation function. Now, how do we solve for this? Let's start with the vertex. How will we solve for the vertex? Remember, our vertex is in HK. The formula for the vertex is for H, we have negative B over 2A. And for K, we have 4AC minus B squared all over 4A. For the axis of symmetry, that's X equals H. I'll go over the discussion first, okay, before we'll have our practice. Next, the opening of the parabola. If your A, remember this is our A, right? If your A is positive, then your parabola opens upward. Example, y equals x squared plus 9. So your parabola opens upwards. But if we have y equals negative x squared plus 9, then your parabola opens downwards. So again, if your A is positive, the parabola opens upwards. If your A is negative, the parabola opens downwards. Next, the domain. These are all the values of x. What's the domain of our function? In a quadratic function, the domain is the set of all real numbers. It means that the domain can be any number. It can be positive, it can be negative, it can be a fraction, a decimal, or with a square root, as long as it is a real number. Next, how about the range? The range depends on the value of A. If your A is positive, remember our vertex is H and K, right? Then the range of your quadratic function will be y such that y is greater than or equal to K. Example, if your K is 5 and your A is 1, it means it's positive, then our range will be y such that y is greater than or equal to 5. How will I interpret this? It means that the range or the possible values of your y starts from 5 to positive infinity, so all positive numbers. But if your A is negative, then here, your y should be less than or equal to to k. Next, zeros. How do we solve for the zeros of the quadratic function? I'll no longer work on it. I'll just tell you, you need to solve for the roots of your function. Once you have the roots, then it is telling you of your x-intercepts. The next one, the y-intercept. How to solve for the y-intercept? You need to let x equal to 0. Then solve for y. Example, y equals x squared plus 9. How to solve for the y-intercept? You substitute x to 0. So y equals 0 squared plus 9. So y is equal to 9. Now, how do we write our x-intercepts in an ordered pair? Here, in the y-intercept, the y has a value 9. What's your x? 0. But in your x-intercept, your y is 0. Example, the roots are plus and minus 5. So your x-intercepts are 5 and 0 and negative 5 and 0. Again, let's have a very brief review. Vertex, h over k. Axis of symmetry, x equals h. Opening of the parabola. If a is positive, it opens upwards. If a is negative, it opens downwards. Domain, all real numbers. Range, if a is positive, then this one, y should be greater than or equal to k. But if a is negative, y should be less than or equal to k. The zeros are the roots. For the y-intercept, you substitute x to 0 and you'll solve for the y. Now let's have our first practice. Ready? Okay, now let's start. You'll find for the vertex, axis of symmetry, opening of the parabola, domain, range, zeros, and y-intercept. Then we need to graph it afterwards. So let's start. Remember, our vertex is h and k. What's our h again? That's negative b over 2a. And our k is 4ac minus b squared over 4a. Let's solve. Remember, our a is 1, our b is negative 6, and our c is 5. So let's have negative of negative 6 over 2 times a. For the k, 4a, c is 5, minus b squared, negative 6 squared, over 4a. That's 6 over 2. And the other one, this is 20 minus 36. Oh, sorry, 4a, 4 times 1, over 4. So we now have 3, just negative 16 divide 4, and negative 4. So our vertex is found in 3, negative 4. Next, axis of symmetry. Remember, it's x equals h. So what's our h? X equals, what's our h? In the chat box, what is the value of our h? Our h is? What's our h? Remember, this is h, k. So what's the value of our h?
3.
3, very good. So our axis of symmetry is x equals 3. Now let's go to the opening of the parabola. What's the value of our A? Can you tell me in the chat box, what's the value of our A? A equals?
1.
1, very good. So A is equal to 1, therefore it's positive. So our parabola opens upwards. Next, what's the domain? Remember, the domain is the set of all real numbers. How about the range? We go back. Our A is positive, so we have Y such that Y is greater than or equal to, what's our K? We go back to the previous slide. Our K is -4. So it's greater than or equal to -4. There. The next one. Ready? Zeros. Yes.
Ma'am, can I ask you a question?
Yes, AP. Oh, where's
First
AP?
one, why the answer is 3 and -4?
Oh, remember AP, we have substituted it to the formula. This one, -b over 2a for h, and 4ac minus b squared all over 4a for k. If you'll substitute the values, you'll arrive to 3 and -4.
How?
How? Here.
Wait, never mind. Okay now. Never
Okay
mind.
na.
Okay now.
Sige. Next, let's go to the zeros. Remember, I told you a while ago, the zeros are the roots. So we will find for the roots. We have x squared minus 6x plus 5 equals 0. Now in the chat box, I'll give 2 points to the one who can give me the roots, not the roots, the factors. Factors of x squared minus 6x plus 5. In the chat box, the first one to tell me the factors of this. Ready? What are the factors? Again, I'm asking of the factors, not the roots. Ready? No one yet is answering. What are the roots of x squared minus 6x plus 5 equals 0? Factors.
-1/2.
No, it's not -1/2. It should be x. What's next?
X minus 3 and x plus x minus 1.
Here, Ali got it first. We have x minus 5 and x minus 1. Congratulations, Ali. Now, the roots are x minus 5 equals 0. So x equals 5. The other, x minus 1 equals 0. So x is equal to 1. So our zeros are 5 and 1. Now the next one, how to solve for the x-intercept? You substitute 0 to all the x. Here, from here. So once you substitute, you'll realize it's 0, 0. So your y-intercept is 5. Now, let's graph. How can we graph it? First, we need to determine the vertex. So the keyword for the first is vertex. Next, opening. Is it opening upward or downwards? Then sketch the zeros and also the y-intercepts. Then the axis of symmetry and draw the parabola. Now let's start. Based on our solving a while ago, we have our vertex at 3, -4. Where's that? 3, -4. Here. That's our vertex. Next, our parabola opens upwards. The next one, let's sketch our zeros. Remember, our zeros are in the x-axis. So 1 and 5. It means it's 1 and 0, 5 and 0. Our y-intercept is 5. So this is the y-axis. You plot in number 5. Next, we draw our axis of symmetry. X equals 3. Simple. In the 3, as long as it passes, it should be a broken line to show that it is the axis of symmetry. It should pass by the vertex. The next, we will draw our parabola. Opens upward. Sorry for my drawing. Here. And be sure to have this one, the arrows in the end, because it means that the graph never ends. That's the graph now. We'll label it. That's f of x equals x squared minus 6x plus 5. Any questions? Feel free to raise your hand. No questions? Give me a thumbs up if you understood it. Okay, great. Now, let's go to the last example. Ready? Before we'll have our quiz. Let's solve for the vertex. What's our formula again for the vertex? HK, that is negative b over 2a, comma 4ac minus b squared over 4a. That is okay. This is already in vertex form. Remember, in vertex form, it's a x minus h squared plus k. So if it's in vertex form, our hk will be the opposite of this, then copy the k. So the opposite of -3 is +3. Then copy 8. So our vertex will be 3, 8. Next, our axis of symmetry is x equals h. So it will be x equals 3. The next one. What's the value of our a? Can you tell me in the chat box? What's the value of our a?
Oh, negative
Negative?
2.
Negative 2. So our a is a negative number. It means that since our a is a negative number, -2, then where does our parabola opens? Up or down? It opens
Down.
Very good. Downwards. Next, our domain is the set of all numbers. Again, our domain is the set of all numbers, real numbers. Our range, this is our k, right? So our range will be y such that y is less than or equal to 8. Why less than? Because our a is negative, so it must be less than. Next, what are the zeros of the function? Now, to solve for the zeros, we can do it this way. Wait first. turn this into 0. So 0 equals negative 2x minus 3 squared plus 8. Next, transfer 8 to the other side. So it becomes negative 8 equals negative 2 quantity x minus 3 squared. Before we can do the square root of both sides, divide both by your a, negative 2. So negative 8 divided by negative 2 is 4. Quantity x minus 3 squared. We have the square on the other side, so we can do extracting the square roots. Square root to the right, square root to the left. Now, what is the square root of 4? Anybody in the chat box? I'll recognize answers in the chat box only. Ready? There is something missing. Is it only 2? Oh, very good, Ali. It should be 2 and negative 2. Remember, plus and minus 2. The other one is x minus 3. Now, let's do case 1. Let's take the positive first. X minus 3 equals 2. Transfer. X equals 2 plus 3. So x equals 5. Next, in case 2, we take the negative. So x minus 3 equals negative 2. Next, x transpose to the other side. Negative 2 plus 3. So x equals 1. Therefore, our zeros are 5 and 1. Next, what's your y-intercept? Let me teach you a technique. Actually, the y-intercept is y equals k, or the constant. That is our y-intercept. So our y-intercept is 8. You write it as 0, comma, 8. No, come on. Here, we still have the plus 2 here, right? So we'll substitute first. Where's that one again? Negative 19, 10. We substitute 0. If it's in standard form, like for example here, y equals x squared plus 4x plus 8. If it's in standard form, your y-intercept is the constant. But if it's in vertex form, you need to substitute it. How to do it? Here, 0 minus 3. So we will have negative 2 times 0 minus 3, negative 3 squared plus 8. So it becomes negative, sorry. Let me transfer to let me change my ink color. Y-intercept. Here, negative 2 times negative 3 squared plus 8. So we have negative 2 times 9 plus 8. So we have negative 18 plus 8. So the answer will be negative 10. Now we graph it. Here, based on our activity, these are the following that we have found. So let us graph. Let's start with the vertex. 3, 8. 3, 8. That's the vertex. Remember, our parabola opens downwards. What's the zeros? 5 and 1. 5 in the x-axis and 1. The y-intercept is 0 and 10. We have a very long one there In case this is -10, there. Then our axis of symmetry is x equals 3. So from the vertex, we draw a broken line to show the axis of symmetry. Then we draw the parabola. It opens downwards. Sorry, might not hit the... I'm really sorry for my parabola. It's not as perfect as it is. Sorry for this one. That's it. Or here, let me show you how to do it using a software. Because actually you can check your answers using a software. Can you now see my graphing calculator online from desmos.com? It's a graphing calculator. So for example, let's graph the first one. What's the first one again? Just write f of x equals x squared minus 6x plus 5. This is the first one a while ago. The vertex, your X intercepts, and your Y-intercept. Let's graph the next one. Ready? The other is f of x, the one we have a while ago. That's negative. Let me check first. -2, quantity x minus 3 squared plus 8. Here, you'll see our vertex is at 3, 8. Next, our x-intercepts are 1 and 5. And our y-intercept, if you check here, at 0, -10. As easy as that one. So you can check your answers using a graphing calculator. How to do that one? You just go to Google. Let me see if you're seeing my screen. Just go to Google. Just type graphing calculator. And then it will lead you to this first one, the graphing calculator Desmos. There are many graphing calculators. We have GeoGebra and Symbolab that can help you in checking your answers. So that's it for today's activity.